Important to note is that not all moles have the same mass. So please write this down somewhere, okay? So 1 mole of hydrogen does not have the same mass as 1 mole of sodium, okay? So right here, this number right here, 1.01, represents the atomic mass of hydrogen in AMUs, okay? But this number also represents the molar mass of hydrogen. So you'll want to write that down somewhere too. Okay? So this is also hang on a sec. This is the molar mass of hydrogen in grams. Sorry, this is a little bit slow. This is why I need an Apple Pencil. And that is measured in grams. Okay? Sorry for my elementary handwriting. Correct slide. Okay? So we have the atomic mass measured in AMU, which is that very small number, okay? But this allows us to visualize this in grams, okay? So 1 mole of hydrogen has a mass of 1.01 grams, okay? And you can see that that's different for every element, okay? So for example, sodium, this is its atomic mass, but it's also its molar mass. And its molar mass is 22.99 grams. Okay, so every mole of hydrogen, or every mole of sodium would have 22.99 grams in it. And if you think of this in terms other than elements, it makes sense. So for example, if I had 1 mole of eggs, like we talked about earlier, that would be 6.022 times 10 to the 23rd eggs. Again, way too much eggs. I don't know why you have so many eggs in your fridge. But if you compare that to 1 mole of feathers, so 1 mole of feathers would be 6.022 times 10 to the 23rd feathers, they would weigh differently, okay? So feathers are a lot lighter than eggs, so they would have a different molar mass, okay? But they would still have the same number of particles in them, which is important to note, all right? So moles will always have the same number of particles, but they will weigh differently, which makes sense if you think about it, because sodium has a lot more protons and neutrons and electrons than hydrogen does. And those protons and neutrons are what are contributing to sodium's mass, all right? So it's going to have a larger molar mass than, say, hydrogen does with its lone proton, okay? All right, so let's do an example together, and hopefully that this will make sense, okay? So if I asked you to do this reaction is solid calcium combined with chlorine gas, which makes calcium chloride as a solid, okay? If I asked you to perform this reaction, this would be a pretty unreasonable ask of me, okay? Because all I'm telling you here is that 1 atom of calcium reacts with 2 atoms of chlorine to form calcium chloride, okay? But how would you be able to obtain 1 atom of calcium or 1 molecule of chlorine? You wouldn't be able to. So that's why we use the mole to help us kind of quantify these values and be able to perform these chemical reactions. Okay, so obviously 1 atom of calcium reacting with 1 molecule of, this is supposed to say chlorine. Let's fix that real quick. And it's not going to let me. But this is, oh, is it having me draw? I don't want that. How do I get it to stop drawing? Maybe this is what was happening to me earlier. Oops. I'm sorry. I'm a mess. Ah, here we go. This should say chlorine. All right. All right, so 1 atom of calcium reacting with 1 molecule of chlorine is just too small in real time, okay? However, this problem or this reaction would be a lot more helpful if I gave you something called the mass ratio, okay? So, let's look at this problem and let's try to figure out how do we know how much calcium and chlorine we need to make sure that none is left over, okay? So how do we use up all of the calcium and all the chlorine we have to make sure there's none left and it's all reacted together? And that's when the mass ratio would come in, okay? So to do this, all I would need to do is figure out the mass ratio. And the mass ratio is going to be the mass of chlorine over the mass of calcium, okay? So if I look at a periodic table, let me get this a little bit bigger. Can we see this one? Not really. How about this one? Same thing. Let's try this one. All right, this isn't really working very well, but I'll just go back to the PowerPoint. Okay. So if I go back to the periodic table that I gave you guys earlier in the presentation, you can see that 1 mole or even 1 atom of calcium is equal to 40.08 grams. Okay, so right here I'm going to write 40.08 grams of calcium. All right. And then I have 2 atoms of chlorine. Okay, so I need to account for the mass of both of those chlorine atoms. All right. And so if I look back at the periodic table, chlorine has a mass of 35.45. So I would take 35.45 and multiply that by 2 because I have 2 chlorine atoms. Each of those has a molar mass of 35.45. All right. If I do a quick calculation, I don't have my phone. Hang on a sec. Calculator. 35.45 times 2, 70, let's call it 71. Let's just round up real quick. All right. So that's 71.0 grams of chlorine. But I'm also going to put Cl2. Make sure I know that there's 2 chlorine atoms. All right. So I'm going to erase this real quick. All right, so if I do that calculation really quickly and find the ratio, you might ask, Mr. Shane, how did you know where to put which one? Okay, so I put chlorine on top because chlorine has the higher mass, okay? So if you're ever looking to do a molar ratio or a mass ratio, put whichever one has the higher mass on top, okay? And this happens to be chlorine, okay? So if you need to write them off to the side first, that's fine, all right? So then if I do that calculation, 71 divided by 40.08, that equals approximately 1.77. Okay, so that is the mass ratio of chlorine to calcium. Okay, so for example, if I gave you, let's say I wanted to know, let's say I gave you 2.5 grams of calcium. And I said to you, you need to make sure that you have enough calcium and chlorine to react and make sure that none is left over, okay? So all you would have to do is take this mass ratio to figure that out, okay? So that means that if I gave you 2.5 grams calcium, again, I'm going to put that on the bottom because that's how we started with it, on the bottom, all right? And I didn't tell you how many grams of chlorine that you got, so that's just going to be X grams of chlorine. Whoa. All right. We know that that number is going to equal 1.77, okay, because we've calculated it with the mass ratio. We know that if we have 2 chlorine atoms and 1 calcium atom, the ratio of their mass is going to equal 1.77. So all I have to do is kind of plug the numbers I have into this kind of general equation to see what I get. So I only gave you 2.5 grams and the ratio is 1.77. So now you need to tell me how many grams of chlorine you would need. And if we just do some basic algebra, multiply both sides by 2.5. Let's see if I can do this. So that would cancel this side out. Multiply that by 2.5. Okay, 1.77 times 2.5 equals approximately 4.43. Okay, so if I give you 2.5 grams of calcium, you need 4.43 grams of chlorine to make sure it all reacts and that there's none left over. Okay? Might seem confusing right now, but we'll do more examples together in the coming days. So don't freak out if you don't understand it right now. Okay? But I am going to continue with this presentation. All right, so let's just go over some definitions of the mole real quick, and it looks like that might be it. All right, so the mole is the amount of substance whose weight in grams is numerically equal to what its molecular weight is in AMUs. Okay, so we kind of went over that earlier. So 1 sodium atom is equal to 22.98 AMUs, and 1 mole of sodium is equal to 22.98 grams. Okay, so if I ask you for the molar mass, all you have to do is look at the atomic mass under your periodic table and change the unit to grams. Okay, because the atomic mass unit, or the atomic mass of hydrogen, is going to be the same as the molar mass, except the molar mass is measured in grams, the atomic mass is measured in AMU. Okay?
How long did it last?
All right. All right, so I would like you guys to try to do some practice problems on your own. Okay, I'll do the first one, and then maybe we can go over some of these together tomorrow. Okay? So the first one, if I ask you to calculate the molar mass of water, okay? That means I want you to look at the periodic table, all right, and look at the molar mass of hydrogen and oxygen, all right? So I have 2 atoms of hydrogen, 1 atom of oxygen. If I look, each hydrogen atom weighs 1.01 grams, and each oxygen weighs about 16, all right? So all I would do is draw 2 atoms of hydrogen times 1.01 plus 1 atom of oxygen, which weighs around 16, and this is going to be measured in grams. Sorry, I forgot my units. All right, and that equals around 18. Let's say 18.02 grams. Okay, so that's all you would have to do. So for this one, you would take 1 atom of calcium, add the molar mass of that to 2 atoms of chlorine, and then the same goes for this one, except with carbon, hydrogen, and oxygen. Okay, so try a few of those on your own. I'll go over the answers tomorrow, and then we'll go from there. All right, so last but not least, that is going to conclude this lesson for today, but something I would like to try in the future is using Zoom. Okay, so Zoom is a way for us to be able to kind of video chat all together. I'm sure you guys really miss seeing my face every day and really miss me yelling at you guys. So this is a perfect opportunity if that's something that you are into, all right? But I think that would be a great option for us because, we'd be able to see each other face to face, and I can answer any questions for you that might be confusing to ask over email. So I'm considering doing that once a week for you guys, but I do want to hear your feedback on that. So maybe I will set up a Google form for you guys to fill out or get feedback from you somehow. Also, I want to know what you guys think about Microsoft Teams. Power School has been doing some serious maintenance this weekend, so I think it might be a go-ahead, but I do want to hear what you guys think about Microsoft Teams for whatever reason if Power School were to kind of not do well again, okay? So I will get that from you guys hopefully or I'll ask you guys about that tomorrow. So yeah, that's going to be it for today, and I hope you guys have a fantastic rest of your Monday.